All right, so let's go ahead and start in the middle of page 2. We are going to talk about the distance formula. This is one of the more ugly formulas that you will see. So we are going to derive it. The word derive means where does it come from? Are we just pulling this out of, a horse's nose? Or are we actually coming up with it from a logical perspective? So what does distance mean? Well, let's just take two random points. And they're not lining up with anything in particular. So I'm going to call this one x1, and this one is y1. So x1, y1, so that's my first point, which has these. So if I want to find the distance to here, and so this is my second point, so x2, y2. How am I going to do this? How do I find the distance from one place to another if I'm going at an angle? Now, if I were just going flat, no big deal. I just count 1, 2, 3, 4. Yay, I got to 4 or something like that. Okay, so what we have to do is apply our best friend Pythagorean Theorem to this context. So let's refresh. Pythagorean Theorem applies to right triangles. So I'll abbreviate that using right and then the symbol triangle. So when you have a right triangle, that means the sides add up nicely. So a squared plus b squared is equal to c squared. However, where do I see my a's and b's and c's? I don't see it. I don't even see a right triangle. Well, let's see here. All the way horizontally, and then I also have a vertical component right here. So now if I draw that, oh look, I have a right triangle. This is my side A. This is my side B, and my hypotenuse is my side C. All right, so now the question is, how do I find out what A is? How do I find out what A is? And then how do I find out what B is? Well, it's a matter of counting, right? Now, I'm not going to use this context here because I don't want to count 1, 2, 3, 4 because this is a generic situation. So notice my point here. To get from x1 to travel along the red, where do I end up? I end up at x2. So to get from x1 all the way across to x2, what I have to do is this. I subtract to find the distance. I just find the horizontal distance by subtracting my my first x from my second x. And the same thing is going to apply there. How do I find my b? I take my second y and I subtract my first y. Again, my first y is here and I go up to there. So how far did I travel? I do a subtraction there. Now what do? If I want to get my distance, that is my c by itself, there are two things I need to do. Number one, I'm going to substitute in my value of a is there. And my value of b, I'm going to substitute there. But I'm also going to get rid of that square there. So let's go ahead and see what happens when I take it to the next level. A, we saw, was just the difference of your x's. And of course, that is still squared. And b was the difference of my y's, which is still squared. And then over here, I have my c squared. How do I get c by itself right here? I have to take the square root. And whatever I do to one side, I have to do to the other side. So the final result is this, and I'm going to write it in the box here. And I'm also going to change this from the letter C, and I'm going to change it to the letter D for distance. So D for distance. The distance formula looks like this. D is equal to the square root of the difference of your x's squared plus the difference of your y's squared. Essentially, it's the Pythagorean theorem with a few things substituted in. So now we've derived the distance formula, so let's use the distance formula here. So we're going to find the distance between the 2 points D and B. Now, if you need to look at this and see this in a visual sense, here's what I'm going to do. I'm going to say 10 minus the negative 2, And then I'm going to say the -8 minus the 6. So the substitution will work just like this. D is equal to, now notice what I'm going to do. I'm going to start by writing the square root, but I'm not going to finish the bar on top because I'll get that at the end. So notice the x2 and x1 was this, minus a -2. So beware, I'm putting a double negative in there. 10 minus a -2, minus a -2. Now I'm going to, don't forget to put a square on the outside of that parenthesis, plus, and now I'm going to subtract the y's, -8 minus 6. Notice in this case, I'm not subtracting a negative. And also bring the square outside. Now I'm going to finish that bar all the way across. Notice I ended the bar at the 2 there. Don't go over and don't go under. So it technically means something, so make sure that we have that. So now from here, I can make some quick changes. The double negative on the first one is positive. So I'm going to now bring down, again, I'm going to start my square root, but I'm not going to complete it until I bring the other stuff down. Notice the red simplifies to 12 and keep it squared. If you can do that in your head, you may have already done that. And bringing down the purple to get -14. And don't forget, I'm going to square that as well. Now I'm going to complete the bar all the way across. Now at this point in time, you might be saying, oh no, I'm running out of room. I don't have room to go down. That's okay if you choose not to go downward. You could go horizontally, just put equal there, etc. It doesn't actually matter. So I'll go down because I have a little bit more space here. Okay, now the red becomes 144 and the purple becomes 196. Feel free to use your calculator to make that happen. And then keep the radical around that. Now I combined the two. So radical 340. Now, there is a way for us to simplify this, but for now, we're just going to plug that into your calculator to get an approximate value. So notice that my equal sign changes to a squiggly sign, approximately 18.4. And of course, the question is, how far out do we need to go? Because it's an infinite number, 18.439, etc. So if I actually go out to a hundredths place, that's probably a good place to stop. Now notice here, both of these will be legitimate answers. Both of these are legitimate answers. This answer is the technical answer. It could be simplified later, which we will chat about how to simplify that stuff later. So, but this is more of the practical answer right here. So how far did you travel? Oh, I traveled radical 340. How old are you today? Well, I'm the square root of 97. Like, that's not how we talk in English. But if I said, oh, I went about 18.5 miles, or I went 18.44 miles, at least that makes sense, and that's more colloquial, more natural speak. This over here is more intellectual, academic speak. Both of these are acceptable answers depending on the context. All right, so let's see an application of distance formula. Now, on problem number 6 in the bottom, it says this. Find the distance between each point. What kind of triangle is formed? So notice here that I do have 3 vertices from F to D, right there. I have from E to D, and I have from E to F. Now, before we jump into the arithmetic, and if you had to take a guess, what type of triangle would you call this? Would you call it scalene? Would you call it isosceles? Or would you call it equilateral? So if I had to take a guess, remember about expectations, I would expect to get a scalene, and I should learn to spell also. So scalene. Now, scalene is my guess. So I'm expecting each one of these distances here, FD, ED, and EF, to be different. So all we have to do, in keeping ourselves organized, is let's just go one at a time. Let's find the distance from F to D. Yep. Then we have to find the distance from E to D. And then lastly, we're going to find the distance from E to F. Now, in this case, I can take a little bit of a shortcut. So let me just start here. So we have 1 minus 0. So I'll plug that in. Now, of course, some of you may notice 1 minus 0 is just 1. So you are tempted to just write that down. That's fine. 3 minus a negative 4. So I'm actually going to do that double negative right here. 3 minus a negative 4. So I did put that square, excuse me, the sum in there instead of the double negative. So feel free, once you're feeling comfortable with the equation, to start doing that a little bit more. To save on space going down, I'm just going to keep going horizontally and doing some things in my head, en mi cabeza. So 1 minus 0 is 1, and I'm going to go ahead and square that right now. I get a 1. 3 plus 4 is 7, and I'm going to square that right now to get a 49. And that should be a plus right there. Square root. And now I have radical 50. By the way, we can read that term as radical, not simply just as square root. And if you want to approximate, you don't have to. You get 7 point something small, 7.1-ish probably, on this. The reason why we don't have to estimate at the end is because all we're checking to see is, do I have different square roots every time? Because that'll give me a different decimal answer as well. So now we're just going to complete that by finding the distance from E to D and from E to F. And our conclusion should be, since all the distances are different, scalene is my answer. And so as we finish these ones up, we see that my conclusion is I have square root of 50, square root of 10, and square root of 68. So my original thought is that I have a scalene triangle, and indeed I do.